Hi everyone, today I'm going to take you through how to solve quadratic equations. We're going to do this, I'm going to go into what a quadratic is, what we're trying to do when we solve quadratic equations, and then we're going to do it through factorising by a common factor, using a difference of two squares, using trinomials, and then solving using the quadratic formula if it doesn't factorise using the conventional methods. Okay, so let's take a look at it. A quadratic equation is an equation with an x squared term. So you could have the graph y is equal to x squared and it would be a perfect parabola. Okay, but the general equation of a quadratic is ax squared plus bx plus c. Okay, and to solve a quadratic equation we set it equal to 0 and then we factorise it. Right, so the graph of a parabola, let's try that again. The graph of a quadratic is called a parabola. It's perfectly symmetrical around its turning point, okay, and we calculate the point where the parabola crosses the x-axis by factorising. Now, obviously the x-axis has the equation y is equal to 0, which is why we set it equal to 0 before we factorise it, because we want to find these points here. Okay, so as I said, the x-axis has got the equation of y is equal to 0, so by setting it equal to 0 we're calculating where it crosses the point. That's called our roots, or can sometimes be called our zeros. Okay, so let's go into solving the quadratic. So we've got the graph x squared plus 10x, we've set it equal to 0 and we want to solve it through factorising. So we're going to factorise it by a common factor, and obviously there is an x in both of these, so I'm going to take x out as a common factor. Then I'm going to ask myself x times what will give me x squared and x times what will give me 10x. Okay. So then what I do is I split both of them off, because one or both of them have to be equal to 0 for it to be true. So I've got x is equal to 0 and then balance this equation, x equals negative 10. So I know that this parabola crosses the x-axis or cuts the x-axis at 0 and negative 10. Okay, so what we've just found, there's the graph there. Okay, we set it equal to 0 and then we found these 2 points, which is what I'm looking for, and it cuts the x-axis, as we've said, at 0 and negative 10, so that's what we're doing. Okay, now a different type of factorising is a difference of two squares, because x is a squared number. A squared number is something that's times by itself, so x squared, x times x. 9 is a squared number because it's 3 times 3. Okay, and the minus in the middle would be your difference. So you would factorise this by opening up two brackets. There's my x squared, there's my 9, okay, and I would have one positive bracket and one negative bracket. Okay, and just like we did before, we're going to split it off, because one or both of them have to be 0 for that statement above to be true, the equation above to be true, and then balance the equation. So this graph cuts the x-axis at x is equal to negative 3 and x is equal to 3. Okay, into a trinomial. Now trinomials can be quite tricky. I'm going to use the sum and product method. Okay, so to factorise this, I want two numbers that multiply together to give me negative 8, but add together to give me negative 2. So I'm going to open up my brackets. There's my x squared. Okay, now the factors of 8 will be 1 and 8 and 2 and 4. Okay, now what I want is I want to be able to make 8, but I also want to make 2, and I can never make 2 with 1 and 8. Okay, so it must be 4 and 2. Now let me give you a hint as well. If this one is negative, the bigger factor is negative as well. Okay, so you can factorise a trinomial and have two positive brackets, a positive and a negative bracket, or two negative brackets, and if you need that, go back to the factorising video for me, please. Okay, so what we're going to do is we're going to split these off. And then balance the equation. So this graph cuts the x-axis at x is equal to minus 2 and x is equal to 4. Right, harder trinomial. As we always try and tell candidates to look for a common factor first and go through the process of factorising, because they do find it difficult. Then look for a difference of two squares and then into your trinomial. But what happens is we always start with our common factor. It would help if I could spell. Okay, and as you can see, I can take out a common factor of 2 in here. Okay, it doesn't make the slightest a bit of difference, but it does make it easier to factorise. It's not going to affect our final answer. Right, so with that 3 at the front, now order does count for these ones. 3 is a prime number, so I'm going to have 3x and x. Okay, my factors of 2, now as you can see I need to make 5 in the middle, so my factors of 2 are 2 and 1. So what I want to do is I want to put 2 in here, because I'm going to multiply these two together. That will give me 6. Okay, and then take away the 1. And as I said, if you don't like the factorising, please find the factorising video on Google Classroom. Okay, so I'm now going to split these off. 3x minus 1 equals 0. We ignore the 2 at the front because obviously that's not going to be equal to 0. Okay, and it doesn't affect the final answer. And then we balance this equation. So 3x is equal to 1, add 1 onto both sides, and then divide it by 3. So x is equal to 1/3, and then take 2 off of both sides. X is equal to -2. So this graph cuts the x-axis at x equals -2 and x is equal to 1/3. Right, so as we said at the beginning, the general equation for a quadratic is ax squared plus bx plus c equals 0. And if we're trying to solve this to find the roots, then we need it equal to 0. So they can sometimes try and throw candidates off by putting things across on the right hand side or not having it equal to 0. So that's the first thing that we're going to have to do. Okay, I would then look for a common factor. As you can tell, there is no common factor here. So I'm then going to go straight into my trinomial. Okay, it can't be a difference of 2 squares because there's 3 terms instead of 2. Right, so x squared will give me x and x. My factors of 4 are 1 and 4 and 2 and 2. No matter how hard I try, I'm never going to get 3 from 2 and 2. So it must be 4 and 1. And as I said, if the middle term is negative, the bigger factor is negative. Split them off. And balance the equation. Okay, so what happens if a quadratic equation doesn't factorise? How can we find the roots? Now, this is when you would, because you're never going to get that to factorise. We will go into the discriminant so that you can check whether or not it factorises at a later date, but that's not for this lesson. Okay, and then to solve quadratic equations, you can use, but that you can't factorise, use the formula. But if a candidate struggles with factorising and they really don't understand it, you can also use the quadratic formula to solve a quadratic equation. Okay, it's a lengthy process. So if they don't like factorising, they can use the formula. Okay, and let's take a look at what the formula is. So there's my general equation for a quadratic equation again, and there's my formula. Okay, so minus b plus or minus the square root of b squared minus 4ac all over 2a. Now that is on the formula sheet and you do not need to memorise it. Okay, now the a, b and c in there relates to the general equation for the quadratic formula. It's the numbers in front of it. Right, so let's take a look at it. Now that 2 decimal places is a huge hint at National 5 Maths that you want to use the quadratic formula. And as you can see, I've got a is equal to 1, b is equal to 5 and c is equal to 3. Okay, so I'm going to substitute that into my formula. So I've got minus 5 plus or minus the square root of 5 squared minus 4 times 1 times 3. Sorry, my square root should go right to the end. And that's all over 2 times 1. Okay, now what I'm going to do just now is I'm going to evaluate the bit underneath the square root. So I would have 25 minus my 12, 13. Okay, now that is called my discriminant, and again we'll come to that at a later date. Now because of this tolerance sign in here, I'm going to have 2 answers. So I would then split it off at this point and I'd have 5 plus root 13. And I would have x is equal to minus 5 minus root 13. Okay, so again, straight into your calculator. Please be careful when you're typing it into the calculator, because when you hit the square root button, it will automatically open up a set of brackets. So if you don't close it, then you won't get the correct answer. Okay, so I wanted 2 decimal places, so I've got negative 0.70 in there. And then the second one again, chuck it into your calculator. You can probably hear me chucking and putting it into mine. And I would have minus 4.30. So I've got a bit squashed at the end. So let's have a look at that again. Okay, so a is 1, b B is 6 and C is 4, okay? It then goes straight into the formula. So I've got x equals minus b plus or minus the square root of b squared minus 4 times 1 times 4. And that's all over 2 times 1. Okay, so as I did before, I'm going to evaluate what's underneath the square root. And I would have minus 6 plus or minus root 20 over 2. Okay, and then because that tolerance sign, I'm going to split it off. Minus 6 plus root 20 over 2. And x is equal to minus 6 minus root 20 over 2. Straight into your calculator again, please be careful when you're typing it in. And you've got x is equal to, I want it to 1 decimal place this time, so negative 0.8. And x is equal to negative 5.2. Okay, now both of the formulas worked, okay? Everything worked out quite nicely, but what happens if it doesn't work? And I want to show you what happens, okay? So solve the equation. Now it looks like a normal quadratic equation and a normal formula equation. I've got a is equal to 2, b is equal to 6, and c is equal to 7. Okay, so let's chuck it straight into the quadratic formula. So minus 6 plus or minus the square root of 6 squared minus 4 times 2 times 7. Okay, all over 2 times 2, so 4. Now, what I get is I've got x is equal to minus 6, like I said, I'm going to do the discriminant, over negative 20, and that's my problem there, okay? No candidate should ever be getting a negative under the square root sign at National 5 Maths, okay? So we tell them that you can't take the square root of a negative, okay? So this has no solutions, which means that the quadratic is not either going through the axis, it's not sitting on the axis, because it would have a solution, so it must be nowhere near it. Okay, it has no roots. Okay, now we will go into complex numbers, which is obviously what you get when you take the square root of a negative, but that's not until the advanced higher course. Okay, so we've taken you through how to solve quadratic equations, each part of factorising, why we do it, what's the point of it, okay, and then into the quadratic formula and when it doesn't work. Okay, thanks very much.